Their bios are online or in the packages, so you guys can read them there. Um, First up, I'd like to introduce Joseph Curro. He'll be talking about recycled glass processing to enhance the quality of end products. He's the principal and senior solid waste engineer at CDM Smith. He's been in the industry for 54 years and with CDM for the last 45. Let's welcome Joseph. Thank you.
Good morning. I want to talk about glass. You know what they say? Glass is dead, long live glass. There was an article this month in National Geographic magazine. It said a couple of interesting things a few interesting. Glass was first produced approximately 5,000 years ago, and that glass is still in existence. Glass is the only product made by humans that actually will last forever. And think about that. Steel won't, aluminum won't, wood certainly won't, but they've showed some glass beads that were made 5,000 years ago, and they were still bright and shiny as the day they were made. That's just amazing. And glass is a strange stuff. It's called an amorphous solid. Some people think glass, like I do, glass is actually a liquid. If you look at windows in houses, I come from New England, you look at some of those old houses and you'll see the glass that was made in a sphere and was cut up and flattened out to make window glass. Some of those old houses, you can see the glass is actually sagged because it's almost a liquid. It's very unusual stuff. So, stumbling right along, what do we do with it? I mean, there's plenty of glass around, and a lot of glass is made. It can last 5,000 years, but its lifespan is usually about 10 minutes. You empty the jar out and toss it away. And I like to say to people, I've been in this business for a while, I know where away is. You throw it away, I know where it goes. So I mainly want to talk about glass today. And if I remember to use this thing, I'll actually get to this where I'm talking about. Okay. So, a couple of basic ways of sorting out glass. The commingled process and single stream. Both kind of work okay, and I don't want to address that. I want to address the glass that comes out of those systems. So, this is typical, comes out of a sorting system. Many of you have probably seen this stuff. It's your typical bottles, containers, a jar full of Smuckers, a plastic jar. So, what I want to address actually is, what do you do with the Smuckers? You get glass, it can be recycled, but what do you do with the Smuckers? So I'm going to show you. I can't do without my notes. So, what do we do with it? Here's just a few uses, and it'll tie in at the end to how I want to process this stuff. Blasting abrasives. Glass is hard, sharp, good abrasive, and I'll get into the wrinkles on that in a minute. Beach restoration. I have two versions of this slide, the Florida version and the New England version. In Florida, it's beach restoration. In New England, it's abrasives for ice control on roadways. Now, if you're from Florida, you probably don't know what I'm talking about. You're saying, what the hell, what's this guy talking? But it is in getting to be in wide use. And again, there's specific reasons for that. Partial substitute for cement and concrete. There's actually an ASTM spec. If you crush glass fine enough, it acts like cement. And you can substitute up to 50% in the mixture, concrete mixtures. Concrete aggregate, not always. We'll get into that, of course. Countertops, terrazzo floors. Now, it can be color sorted. I saw some equipment yesterday that can color sort. Fish tank pebbles, landscaping. All kinds of uses. And, if you know glass, you know that that's just a tiny list of what can be done. So, how do you get it clean? Like, really clean for these uses? It can't none of those can tolerate any contamination. So, let's start with the blasting abrasives. You can use, sandblasting or blasting, I won't say sand, commercial cleaning operations, The first one I ever saw was in Pennsylvania. They were recycling tempered glass from car windows and crushing it to use in a blasting operation next door. Advantage of glass is there's no free silica dust. So you're not blasting like with sand. It breaks down and you got this silica cloud all over the place. You don't get that with glass. There's no free silica. And glass is harder than most abrasives. Now, if you're familiar with blasting, there was a product called Black Beauty. It was made from slag, obsidian, from coal-fired power plants. Well, the coal-fired power plants are being phased out, so is the Black Beauty, so the companies are looking for an alternative to Black Beauty. And what they found is that the glass actually works better than this stuff as long as you can get it clean. It's harder, sharper, but need to be remove the labels, and in the process I'm going to talk about, it can also be sterilized. Dry and free-flowing, good stuff. So that's a sample of it, or a picture of it. It's, you know, if you're using it for blasting, you don't care what color it is, although everybody always liked Black Beauty because it was nice and black. That is not clean, that's as it comes out of the process, so it's not clean, screened, or anything. The beach restoration. Now, I just talked about how sharp and nice sand is to blast with, but when you reduce it in size, and I actually have some samples, when you reduce it in size, it gets kind of silky. It has a nice rounded feel, and the sea turtles are not bothered by it. That was the biggest thing when there was some tests done, that would the sharp sand bother the sea turtles. It can be multicolor. You can have a multicolor beach, or you can have color separated. You know, it's an option. Again, you need the labels and the smuckers removed from the product. Free-flowing, and you can make it, if you're a landfill near a beach, you can make your own sand and put it on your own beach, and you don't need to get it from somewhere else. You know, where I work in St. Lucie County in Florida, they do a lot of beach restoration after hurricanes, and they're pumping sand from out in the ocean. And we got a mountain of glass that we can make the sand. So that's, okay. Now, I need some assistance. Need someone to come up and, okay, look at that. Okay, what this is not quite cement. Just, you can pass that around.
I'll pass it around.
Yeah. I prefer you don't open the jar, but if you want to, go right ahead. So that's beach sand, a little finer and it'll be cement. Free-flowing, meets the ASTM standard 1866 for, you know, crushing that finer for cement. Up to 50%. They say 40 to 60% of the cement used can be substituted by crushed glass. And the benefit of that is, to crush that, to make cement, creates no greenhouse gases. So here we have a product, you know, if you're familiar with cement, it's going to be burned and used. It takes a lot of gas or fuel to do it. Okay, and this is actual cement. This was color sorted glass that was crushed down. Actually, that's the same fineness as what's in the jar, but that can be crushed down to an absolute dust. You can't tell the difference from that or cement, and you really can't tell the difference in the performance either. Using concrete for fine aggregate 1/4 inch minus size. Again, it needs to be clean. You don't want to put label residue or the smuckers into your concrete. In many cases, the multicolor is acceptable. Crushed, again, free-flowing. But secondary applications, there is a reaction. If you try to use larger pieces of glass, there is a reaction with the mix in the concrete, and the larger pieces of glass can actually weaken, and you can't really use it for structural applications. Well, there'll probably be people that say they can, but all right, so that's concrete aggregate. I don't have any of that. This is sandblasting sand. So that's commercial sandblasting sand for structural applications. For heavy sandblasting, it's pretty coarse. All of these, the two that I've passed out and this one I have left, were actually produced in my kitchen. And I'll explain that in a minute, but yeah, they was produced in my kitchen. So this, moving right along, countertops, terrazzo. You're familiar with this, you know, mainly in airports, you walk along, you see floors like this, and that process was adapted to make what they call the quartz countertops nowadays. So this is a multicolor. If you color sort, you can have, you know, any color you want. Fish tank pebbles, again, remove the residue, free-flowing, you know. We're seeing a theme here. It wants to be clean. Everything wants to be clean. And there's some landscape pebbles. Now this, well, not there yet. How do we get it? I mean, we know, whoops, how to sort it, how to get the glass out, but getting the contaminants out of the glass is, we'll see how to do that. You can crush it, granulate it. We need to remove the labels, and you can sterilize it and tumble it if you need to, if you need it really rounded. And you want to meet a specification, just like new glass. Again, you know, there we are, and there's the smuckers again, and the plastic, the lids. So there's a process here that can take all of that, take the contaminants out, and make a nice, clean glass. So, from that, we go to this. This is a crushed glass, and you can see we have some contaminants in it. And this is it. This is out of a primary crusher. Please don't open this jar. This stuff's been in this jar for 3 years. Open it at your own risk. So what I did was take the rest of that material, some more of that material, and process it to make the other two samples you have. So this isn't, you know, commercial stuff. This is stuff that I actually made and will be made in this process. So again, you know, there's the pebbles. This is after that sample's been processed. You see there's no contamination left in that. There's no label residue. There's no smuckers. It's clean. And this is the second jar I passed out is this. It's a before screening to give you the different sizes that you want, and that can be crushed down, again, as fine as cement if you want. So we have the sorting, gets the glass out of the recyclables. You can hand pick it. It can be picked automatically. And automated sorting is certainly the wave of the not too distant future. And even color sorting, which can be important. The more you sort it in an economical way, the more you can increase the value of these products. So, going through that first jar, to get to that, we remove it. The magnet removes the metals after it's been crushed. An air blast removes the big fluff. Take out any oversized. And you get a fairly uniform product size, but it is wet, it's odorous, but it has potential. So this is a typical crushing line. Material comes in here, gets conveyed through the crusher and through a trommel, and they can size to a couple of different sizes in this one. This was not a terribly successful process because the stuff was so wet and yucky. You know, again, back to the smuckers again. You know, you put smuckers with crushed glass and put it through a trommel, you're going to end up with a big glassy smuckers ball, which is what they did. And this is what's removed. You know, picking plants, they'll say that, yeah, we get the stuff clean, but, you know, there's still, in the glass pile, there's still stuff that needs to be picked out. So, let's get serious here. There's two ways to get it. You can dump the glass after the first crush into a dunk tank and float the labels off, wash the smuckers away, and now you end up with a glop. That's the way a client described it to me. He had a glop left over. And, what do you do with that stuff? You can put it back in your landfill. Well, we can do what I want to talk about, high temperature processing. You put it through a high temperature oven, and it's not an incinerator. There's some specific differences here. It will remove the labels and the residue. Now, there was a book written many years ago called Fahrenheit 451, and the reason for the title was that paper, the auto-ignition temperature of paper is 451 degrees. So we don't need to go to incineration temperatures to release the labels from the glass. And then, you have that, and you screen your product, and you can separate by screening or by an air blast to get a clean glass product. It's 100% dry. Any moisture is evaporated, burned off. And here's a neat trick. If you're at your landfill and you have a little landfill gas left, or surplus, it doesn't take a lot, like 100 CFM. And I'm working with a closed landfill. They have 300 CFM and no use for it. I have a use for it. And again, can produce a sterilized product if you need it. So, how do you produce a usable product, fairly uniform in particle size? You can see in the jars that it's fairly uniform. It's clean. If you look real closely, you don't see anything in there but crushed glass. Dry and odorless. If you open the two first jars, it's dry and odorless. Don't open the third one. Child, pet, and fish safe if you're using for fish tank pebbles. How do you make a sterilized product and produce specialized specific products, or it's unlimited? What else, once we start doing this, what else can you make that a valuable product from this glass that's 100% every time the same, clean, and if you want it to be sterilized? So, the high temperature processing, remove the contaminants, takes out the smuckers, takes out the labels, can process any type of glass. Now, a lot of recycling systems can't take plate glass or some other types of glass. This can. You're not looking to melt this stuff. You're not making new containers. You're making a different usable product. I went up to Canada one time and they said, we have problems with ceramic bottles coming through. I don't. It comes right through. They said, well, we can't take plate glass. I can. Can't take tempered glass. Oh, we love that. It's a dry, odorless product, free-flowing, again, child and fish safe, and it can be sterilized. Now, it does work best if you're at a landfill, and obviously you have the landfill gas if you're flaring it off. You've got the free fuel to do this process. Now, it can be electrically heated or fossil fuels, but that changes the economics. So, I apologize for all the words on this slide, but we use a high temperature oven at 800 to 900 degrees. That temperature range is very important because it cuts the cost of the system down to well, we'll get into that later. Again, the landfill gas firing. If you have landfill gas, this is a no-brainer. Removes all the organics. And being an oven in many localities, this is not permitted as an incinerator. The emission control equipment can be a lot less. Separate the residue. I call it ash, but it's not really. It's kind of a char. Makes a clean, sterilized product, free-flowing, and when the product comes out, you can suck it up with a vacuum, similar to handling coal ash. That there's vacuum systems. United Conveyor makes one that can just suck the stuff up into a storage silo where you feed it to a sizing process and make any size you want. Like that's the last item there too. Secondary crushing, sizing, packaging for sale. You can pack it in bags or bulk or whatever your market dictates. Okay. Oh, come on. There's the beast. Okay, so what you do is feed your glass into here. Now, we're looking at two different ways. That pre-crush is kind of a pain because the rollers in the crusher get gummed up. So we're looking for something better than that. But what we found out is that if you drop the glass into a hopper like this, maybe with a heavy plate from any height, you do enough breaking of the glass that it can be processed. Because you can remember, you're going to process it later into whatever size you want, so it doesn't really matter what size it goes through here. And this machine doesn't care. So we're looking at a module here. This one does about 50 tons per hour of glass at a cost of about $400,000. So like I said, glass here fed into the system, goes through the oven and comes out the other end, clean and sterilized. Landfill gas firing, this particular one's electric. It's okay, but it's kind of expensive to run, but that was the only picture I had. And I tell you, it looks better on this screen than it does up there. But, and again, it cleans it, sterilizes it. It comes out, glass comes out hot, and what you do is run it through a heat exchanger to heat your combustion air going back in, so you don't lose a lot of heat because the specific heat, okay, good, is pretty high with the glass, so you can recover it easily. It accepts heat and gives up heat pretty easily. Okay, so getting back to our uses. The blasting abrasives, now you can see how it's made nice and clean. You've seen the samples going around. It can be done. The beach restoration / ice control, the more coarse sample that was around would be the ice control. The finer would be the beach restoration. The substitute for cement, it's been used very successfully. Again, the concrete aggregate, it depends on what you're doing. The countertops in the terrazzo, works nicely. And my favorite is the fish tank pebbles. And now a very recent use, like this is in like last week or so, we're looking into using it as a base for a new landfill. The landfill has a pond that they dredged cover material out. Now they want to fill it back in. So they have a shortage of soil. They're going to take up all the soil within like 200 miles. And I've suggested, well, let's process glass, and we'll do it in a coarse crush and mix it with the soil or use it completely as a substitute. So we're doing some studies now to see how we can process the glass to make it as a substitute for sand. They have 600 CFM of surplus landfill gas on the site. So this is an ideal situation for this. So, and they're looking for thousands and thousands of cubic yards of this. So I'm suggesting take all the glass you can from as far away as you can get it and process it and use it to build this landfill. So, running out of time and I'm running out of stuff. So, what we can see here is the uses are pretty limitless. Glass, it's going to live forever. For the base of this landfill, you don't have to worry about any kind of degradation. And once you process it, there's no organics left in it. It's very free-flowing. Again, it can be sterilized if the need or the market dictates. Uniform size, it comes through, you crush it, and you make it any size you want. Color sorting, that can be done. Again, any type, not light bulbs or fluorescent tubes, but pretty much any type of glass can be processed because you're not melting it, you're not making something, you're making a product that's independent of the composition of the glass. And high value uses, the blasting sand is pretty expensive stuff. The other uses are pretty pricey materials that can be produced at a pretty low cost. So, as a lot of you know, glass is no longer a waste product. It can be a clean product. So with that, I will end. And you've listened to me long enough. I still have 1 minute and 48 seconds left. Not bad.